Hi, welcome to section 10.7 notes. This is on the area of circles and sectors. It's going to be 4 pages long, so bear with me, but I think you'll enjoy it. Hopefully so. First part is just a review over the area of a circle formula is pi r squared, and the circumference of a circle, which is kind of like the perimeter of the circle, the distance around the circle is 2 pi r. Sometimes you see the circumference formula is written as diameter times pi. It means the same thing as 2 pi r. So again, circumference is distance around the circle, where area of the circle is how much space the whole circle takes up, the whole inside of the circle. Again, the radius goes from the center of the circle out to the edge of the circle, which you can see in this picture right here, where I'm highlighting the center. And you can see that the diameter, you can't see it in this picture, but we'll see some in future pictures where the diameter would go all the way across the circle through the center, and both endpoints would be on the circle, and that represents the diameter, which is 2 times what the radius is. So on example 1, it says, what is the area of the circular region of the wrestling mat around the nearest foot? So again, if we're looking for area, we know that the formula is pi r squared. Area is equal to pi r squared. Actually, let me start over. I didn't start off looking too good there. So area is equal to pi r squared. And in this particular case, if I look at the picture, I can see that across the wrestling mat is 32 feet. So they're actually giving me the diameter here is 32. So if I want to find the radius, I know that I need to half the diameter. So 32 divided by 2, which gives me 16. So now that I know that the radius is 16, I can plug that into the area formula over here. And now it says round to the nearest foot, which is the nearest whole number. That means I am going to multiply by pi, because it didn't say leave your answer in terms of pi. But don't just use 3.14. You want to use the pi button on your scientific calculator to get the more exact answer. And then round that to the nearest whole number, which is going to then be 804. Remember, units for area is always going to be squared, so feet squared. Then if you look at example 2, it's specifically asking for the circumference of the mat. And again, we just said the circumference is equal to 2 times pi times r. And again, if we know, or you can think of it as diameter times pi, either way. But if you're just thinking of the original formula listed here, and we know that the diameter is 32, then just like we did on example 1, we know the radius is half that, which is 16. And so in this case, we can say 2 times pi times 16. And so again, rounded to the nearest foot, I can multiply 2 times the pi button on my calculator times 16. And that's, if I round to the nearest whole number, I'm going to get 101 feet. Okay, and again, if you want to use the diameter times pi formula, that is completely fine. That would have been 32 pi, and if you plug that in the calculator, you'll get 101 as well. All right, the sector of a circle is just like a section of a circle, not the whole circle. So it says a region bounded by an arc of the circle and has 2 radii as the arc's endpoints. The sector is named by using both arc endpoints and the center of the circle. Okay, so the shading didn't show up very well here, but in this particular picture, like that part would be shaded. And so if we want to find the area of that sector of the circle, that portion of the circle, we have to bring the arc in here like we talked about in section 10.4 and 10.6. So the arc of AB, they're showing you here, we have to keep in mind is going to be the measure of this arc from here to here. And that's going to help us find sector AOB or BOA. Either way, it's referring to that section that I just shaded in blue. The formula for the area of a circle, we can see down below. And again, this would be our shaded region. would be, it says the area of a sector of a circle is the product of the ratio of the measure of the arc, which again is the measure from here to here, which is the same as the measure of the central angle, over 360, because that's how many degrees are all the way around the circle. And then you're going to multiply that by the area of the circle. Okay, so the area of a circle formula gives you the area of the entire circle. But if I just want the area of a certain section of that, I've got to multiply by what portion of that circle that I want. So down here, it says, what is the area of sector GPH? So that is referring to this section right here. And it says leave the answer in terms of pi. So we're using the formula that we see above right here. We're using this formula. So the measure of the arc, I can see arc GH is 72 degrees. I'm writing my 72 over the total amount around the circle is 360 times the area of the circle, which is pi r squared. Pi times the radius, which I can look at the picture and see it's 15, and I need to square that. So if I'm going to leave my answer in terms of pi, I don't want to multiply by pi. I'm going to multiply everything else except for the pi. So in this case, if I multiply the things on the numerator, I've got 72 times 15 squared equals divided by 360. Since it goes in evenly, I can go ahead and leave my answer as 45 pi. If it didn't go in evenly, I would have to reduce that down and leave it as a fraction to have it in exact form. And then I want to, in this case, we don't have units in this problem. Okay, but we're leaving our answer in terms of pi. On number 4, it says, what is the area of the sector of the circle with the radius of 4 and an arc of 45? Leave the answer in terms of pi. So same type problem. They just didn't give us a picture this time. So I've got my measure of my arc, 45 over 360 times the area of the circle, which is pi times 4 squared. And if I go ahead and multiply 45 times 4 squared equals divided by 360, I end up with 2 pi. And in this particular case, because it uses inches in the problem, then I know my area is going to be inches squared. All right, 1 page down, 3 to go. Good job. All right, next page says the area of a segment. Okay, so if we look at the area of a segment over here in the third triangle, it's referring to this little shaded portion here that I just shaded in blue. So the way that's going to work is we're going to find the area of the circle like we just did twice. And then we're going to find the area of a triangle, which we know how to do as 1/2 base times height. And you can see those formulas down here. And then we're going to subtract those two to get this leftover little sliver, which we're going to call the area of the segment. Okay, so you're just going to kind of have to keep track of what you're actually doing here. So I'll move it up, but I'll still show us our formula here. So in this particular case, we need to find, again, this is, I'm going to write it since we can't see it anymore. This is the area of the sector, like we just did on the last page. This is the area of a triangle, and that's going to give us the area of the segment. So in this particular picture on example 5, we're trying to find this part that is shaded, that I just shaded also in blue. So if we go ahead and find the area of the sector like we did on the last page on example 3 and example 4, I'm just going to try and keep clear everything I'm doing by labeling what I'm finding. So my area of a sector is using the formula we just did on the last page, where we say the measure of the arc, which I can see if this central angle is 60, I know the measure of this arc is 60. So, and it is still degrees, even if I'm talking about the measure of the arc. So I've got 60 over the total amount around a circle is 360 times the area of the circle, which is pi radius, which I can see in this picture, BC is 32. And then I need to square that. So if I go ahead and multiply this information, if I try to go 60 times 32 squared equals divided by 360, then that will not divide in evenly. So I need to kind of reduce things down a little bit, but I still want to keep it in exact form. So if I go and just simplify down this 60 over 360, I know 60 goes into both of those. So 60 goes into 60 one time, and 60 goes into 360 6 times. That looks a little better. And then we've got times pi 32 squared. If I go ahead and multiply 32 squared, then I get 1024 on the numerator over 6 on the denominator, and I still have my pi. That hasn't gone anywhere. If I reduce down again, 3 divides evenly into both of those. So I end up with 512 over 3 pi. Again, I'm not putting that as a decimal yet since the 3 doesn't go in evenly, because I don't want to round and round and round throughout the problem. It's going to alter my answer too much. So I want to keep it exact. And then when it says round to the nearest tenth, that means I will round the problem at the end of the problem to the nearest tenth. I will only want to round one time in a problem. So I found the area of the sector, which is this whole section of the circle. Now I want to find the area of the triangle, which I know is 1/2 base times height. Okay, now to find the area of the circle, if I look at this, I can see that this central angle is 60. I also know both of these radii must be congruent to each other from the center out to the edge of the circle. So I know these two angles are congruent. And, if I go 180 minus 60, I get 120. I know both of those angles add up to 120, but they're both congruent. So therefore, I know that they are both 60. Didn't show up very well, but I know they're both 60. So technically, that is an equilateral triangle. I'm going to draw it right here so I can deal with it a little better. So I know I've got an equilateral triangle. Okay, I know that if one side is 32, the radius, and it's equilateral, that all the sides are 32. And I want to find the area of that triangle. So I could use 1/2 apothem times perimeter that we've been doing. But a quicker way to do that I'm seeing is if I draw the altitude or height through the middle of that triangle, then, because if I want to use 1/2 base times height, which I can do for a triangle, then I know it's 32 from here to here. Therefore, I know that half that is 16. Okay, and if I just split the 60 in half up here, I've got 30 and 30. And so if my short leg across from 30 is 16, and I want to find the long leg, then I'm seeing that the height is 16 square root of 3 of that triangle. So if I want to use 1/2 base times height, I can say 1/2 times the base of this triangle, which is 32, times the height, which is 16 square root of 3. So if I go ahead and multiply everything except for the square root, if I go 0.5 times 32 times 16, I get 256 square root of 3. And so that's the area of the triangle in exact form. Now down here for the big finale, the area of the segment that's supposed to say area of the segment is equal to, I just need to subtract these two. I'm subtracting this number and this number. So area of the segment sector is the bigger amount, 512 over 3 pi. minus the area of the triangle, which is 256 square root of 3. And if I subtract those, be careful when you're dealing with those, to make sure you're plugging in the calculator correctly. If you need to use, hit equal sum as you go or use parentheses to get it plugged in correctly, but you should end up with 92.8. So I would check plugging that in just to make sure you get the right thing. The way I'm going to type it in here, so I don't have to do so many parentheses, I'm going 512 divided by 3 equals times pi button equals. Now I'm going to say minus 256 square root of 3. And I get the 92.8. Okay. So the way I typed it in, I didn't need to do parentheses. But, just kind of be careful with order of operations when you're plugging things in the calculator. All right. Next up is a problem very similar to the one that we just did. If you want to try it on your own and check back, that's fine. If you want to just do it with me, that's fine. Just pause it if you want to try it on your own. This problem isn't quite as long as the last one, but same idea. So I've got area of a sector is going to be the measure of the arc, which is the same as the central angle, which in this case is 90, over the total amount around a circle is 360, times the area of the circle, which is pi, times the radius, which I can see in the picture is 4. And I need to square that. So if I go ahead and multiply 90 times 4 squared equals divided by 360, I end up with 4 pi. I'm leaving it in terms of pi for right now. Area of a triangle is 1/2 base times height. Here, I know that if one radius in the picture, QP, is 4, then I know QR has to be 4 also. Remember, the radii are congruent to each other. And in this case, the base, it's not an equilateral triangle, it's a right triangle. Remember, the base and the height always have to form a right angle with each other. And because it's a right triangle, these two legs do form a right angle with each other. So they are my base and my height. So 1/2 times 4 times 4, and that gives me 8. So now I'm already ready to find the area of the segment by saying 4 pi minus 8. Again, area of the sector is the bigger one, so I need that first, and then I'm subtracting away from it the area of the triangle that's not shaded, so I'm left with this little sliver right here, the area. I plugged in the calculator, I've got 4 pi equals, and then minus 8. And in that case, I end up with, rounded to the nearest tenth, 4.6. So plug that in the calculator to make sure you get that. All right, page 2 down. Good job. All right, more section 6, 7 notes. Just some other different type problems that are good to go over. So here it says, as part of this is a little review here. If a circle has an area of a squared units and a radius of r units, then a equals pi r squared. So again, that's just reviewing over the area formula again. On example 1, it says you are having a party and want to make a cake. You have a Pillsbury cake mix that makes 1 10-inch cake. You have a Betty Crocker cake mix that makes 2 5-inch cakes. You want to feed the most people. Which cake mix should you use? You'll assume the cakes are the same thickness. So I want you to try and think through this, first of all, and see which you think would be the better deal. Which one is going to give you the most cake. If they're the same thickness, then all we need to do is worry about which one is going to give us the most area, 2 5-inch cakes or 1 10-inch cake. Similar problem to if we were talking about pizza, which one's the better deal to buy. So think through it, kind of make your guess of which one you think is a better deal, and then now let's do the work and we can compare them. So if we think of the 10-inch cake, if we say a 10-inch cake, we are saying that the diameter is 10. Okay, so I'm going to show you my diameter. And we are saying that the diameter is 10. Okay, so if we find the area of that, we know we're going to use pi r squared formula. And if the diameter is 10, we know in this case the radius is 5 inches. So if I plug 5 in, I've got pi 5 squared, which gives me 25 pi. And 25 pi, if I can either leave it as 25 pi, or if I want to go ahead and put it as a decimal, I can. So 25 pi or 78.5 inches squared. Okay, so now we want to come over here and see what 2 5-inch cakes would be like. So here and here would be my 2 5-inch cakes. So in this case, my diameter is 5 for each one. So my radius on both of these is 2.5. Okay, so if I find the area of one of these cakes, I get pi times 2.5 squared, which gives me 6.25 pi. And that's just for one of the cakes. I want to do 2 times that. So 2 times 6.25 pi. And that gives me 12.5 pi, which is the same thing as 39.3 inches squared. So see if you were right. We're saying the 2 5-inch cakes gives us an area of 39.3 inches squared of cake, and the 10-inch cake gives us 78.5 inches of cake. So that's almost double the amount, even though you might have thought the 2 smaller cakes would be bigger than the one 10-inch cake. But it wants to know which cake mix should we use. And to feed the most people, we're going to say 1 10-inch cake. There we go. All right. Down here, it says in example 2, a caterer has a 48-inch diameter table that is 34 inches tall. She wants a tablecloth that will touch the floor. Find the area in square yards. So if you think about this, then in this case, this is our table, the smaller circle. Okay, so we have a 48-inch table. That goes from here to here. But she wants the tablecloth to hang over the edge on each side and touch the floor. So if you think about the bigger circle being the whole tablecloth, if you think about if you put it on the table and let it fall down, then if it's 34 inches to the floor, then we're saying that it would be 34 from here to here, and it would also be 34 from here to here. So the actual diameter of the table is 48 plus 34 plus 34, which gives me 116 inches. Okay, so we know that all that is 116 inches. All right, so now the radius of that table then is 116 divided by 2, which is 58 inches. And now be careful here because we're dealing with inches so far in the problem, but it wants us to talk about the area in square yards. So at some point you need to convert the units. I'm going to go ahead and convert them now. I know that 58 inches, I know that 1 foot is equivalent to 12 inches. So if 58 inches is written first, I need 12 inches on the denominator, so those inches will cancel out. Okay, and so that works. Then I'm still trying to get feet to yards. So I do know that there are 3 feet in 1 yard. That's an equivalent unit. So now I know my feet will cancel out. And now I'm left with yards, which is what I was going for. So in this particular case, if I multiply the numbers on the numerator, 58 times 1, I get 58 yards. On the denominator, I get 12 times 3, which is 36 yards. Okay. From there, if I want to reduce this number down, I can. If you want to leave it, that's fine. Because you're going to end up, I ended up putting it as a decimal anyways. So either way is fine. I went ahead and just left it. So there's my area formula. I'm plugging in my 50. Oops, I didn't look very good. I'm plugging in my 58 over 36, and I'm squaring that. And if I plug that in my calculator, again, double check plugging this stuff in your calculator. So I pushed the pi button, and then I put parenthesis, and then I did 58 divided by 36, and then another parenthesis. And now I need to square that. So I'm hitting the x squared button that's to the left of the 7 on my calculator. And then I'm hitting equals, and I got 8.2, rounded to the nearest tenth. And again, I had converted into yards. The area is always going to be squared units, so I'm saying 8.2 yards squared. All right, 3 pages down. Nice job. 1 to go. Okay, so now we are to example 3. Might make this a little bit smaller. Okay, so we have a little more workspace. On this, these problems are going to be similar to what your homework assignment is on this section. And so there's just 3 problems for homework. They're similar to these, but it says find the area of the shaded region. Assume that the triangle is equilateral. So that means it's a regular polygon, all sides, all angles congruent. So there's different ways to find an area of equilateral triangle. Based on what they're giving me, I'm just going to use the 1/2 apothem times perimeter. Okay, I know that the overall idea of this is I have to find the area of the whole circle, I have to find the area of the triangle, and I need to subtract the 2. So if I first find the area of the circle, I know that formula is pi r squared. I can tell they gave me the radius from the center out to the circle. I've got pi 4 squared, and that gives me 16 pi. So that part was easy. I'll switch colors here. Okay, now to get the area of the regular polygon, 1/2 apothem times perimeter. If I look at this triangle, I don't have the apothem right now, and I don't even have a side link to get the perimeter. So I need to do some work to get that. I'm going to go ahead and make my triangle here. I know that this whole angle is 360 divided by the 3 sides, which is 120. So I know this whole angle is 120, but if I go and draw the apothem down the middle, then I actually am going to go 120 divided by 2 is equal to 60. So I know that is 60 and that is 60. Okay, so I know that these angles are both 30. So that 4 is the hypotenuse. And so, the 4 is the hypotenuse. If I want to get the short leg, then I know that's across from the 30. And I need to divide by 2. So 4 divided by 2 is 2. So I get the apothem is equal to 2. And then the long leg then is 2 square root of 3. And then I also know that these pieces are congruent. So this is also 2 square root of 3. So I know this one whole side length is then 4 square root of 3. Okay. So I've got the apothem. I can see that in the picture. I know one side length is 4 square root of 3. If I want to find the perimeter, I can do my n times s, and I know there are 3 sides, and each side is 4 square root of 3. So if I multiply those, I get 12 square root of 3 for my perimeter. So now I can plug in my 1/2 apothem times perimeter formula, and I have 1/2 apothem. I can see I found is 2, My perimeter is 12 square root of 3. So I get, if I multiply everything except for the square root of 3, 1/2 or 0.5 times 2 times 12, I get 12 square root of 3. And then now, again, I just need to subtract. The area of my circle is 16 pi. And let me show you just kind of in words what I'm doing. The area of the shaded region is equal to the area of the circle minus the area of the triangle. I think it helps to kind of just overall figure out what you're doing. Now I can say, okay, the area of the circle we had found up here is 16 pi. Oops, I don't want an equal sign there, I want a minus sign. Minus the area of the triangle, which we just found is 12 square root of 3 using our 1/2 of Popham times perimeter formula. And now I just need to get that typed in the calculator. Again, be careful typing it in. If I don't want to use a lot of parentheses, I'm going to go 16, pi button in my calculator, equals, and then minus 12 square root of 3. And I end up with 29.5 rounded to the nearest tenth. Need to include units, and in this case, it is meters squared. Again, area is always squared. All right, 2 more, you can do it. Again, if you want to try these on your own, feel free. If you want to do it with me, that's fine. Okay, same idea here, except for it's not a triangle in the middle, it's a hexagon instead. It's just kind of combining the circle stuff with what we were doing in section 10.3 and 10.5. So in this case, again, we've got our overall idea as my area of my circle is pi r squared. But in this particular case, I do not know the radius at this point. Sometimes people will accidentally assume that 12 is the radius, but you can see that that does not go from the center of the circle out to the edge of the circle. So I can't consider that the radius. So I'm not ready to find the area of the circle yet. I'm going to need to do some of the angle work first before I do that. So I'm going to go ahead and do that part now. If I go ahead and say 360 divided by the 6 sides of the hexagon, and that gives me 60. Okay, if I go ahead and draw this triangle here, oh my, that's not a straight line. Let's try that again. A little better. Okay, so I know this whole angle is 60, but I need to half that to get 30. So in this particular case, I know that this angle is 30 and that angle is 30. It's hard to fit it in there. Okay, so therefore I know that these angles are 60. And here I want to be really careful. If I think about what was given to me, it was the apotheosis 12. But now that I've drawn this triangle, it really doesn't even look like the apotheosis 12 anymore. So I want to be really careful with that. So I'm going to kind of scratch out the 12 where it is now and stick the 12 right on the apotheosis so that I'm just sure that that's what it was referring to and I don't forget about that. Okay, so that is my apotheosis. I'm going to go ahead and just write it up here so I don't even forget. The apotheosis is the 12 meters. All right, so now if I find the other side lengths, then I know that the long leg is 12 and I want to find the short leg. So I need to divide by square root of 3. But I'm not allowed to leave a square root in the calculator, so I'm going to go ahead and multiply by square root of 3 over square root of 3. And that gives me 12 square root of 3 over 3, which gives me 4 square root of 3. All right, so now I know that the short leg from here to here is 4 square root of 3. So that means that this is also 4 square root of 3 because they're congruent. So now I know that from here to here must be 8 square root of 3. Okay, so I know the side length now, so I can find the perimeter, but I still haven't found the radius yet. I need to do that. So I now have said the short leg is 4 square root of 3, so therefore I know the hypotenuse is double that, which is going to be 8 square root of 3, which happens to be the same as the length of the side length. Not always going to work, but in this case it does. So I've got the information that I need now. I know up here that the radius of the circle from the center out to the circle is 8 square root of 3, so I can plug that in here. So pi 8 square root of 3 squared. Okay, so if I square 8 square root of 3, if I square the 8, I get 64. And if I square the 3, square root of 3 squared is I get 3. It's technically square root of 3 times square root of 3, which is square root of 9. The square root of 9 is 3. And if I go on and multiply those, I get 192 pi. So that's my area of my circle. I need to do some work here to find the area of the regular polygon, the hexagon, 1/2 apothem times perimeter. So the apothem, we had already said, was 12. They gave us that in the original problem. And the perimeter, I guess I can show off to the side here. Perimeter is n times s, which is the 6 sides times one side, which is 8 square root of 3. And that gives us 48 square root of 3. All right, so if we go ahead and multiply that, we end up with 288 square root of 3. All right, so now we've got the area of the shaded is equal to the area of the circle minus the area of the hexagon. So I'm actually doing area of the circle we have up here is 192 pi minus the area of the hexagon, which is 288 square root of 3. And if I go and subtract those two, again, be careful plugging it in your calculator. If you don't want to use a lot of parentheses, I did 192 pi button equals minus 288 square root of 3. And I got 104.4 meters squared. Okay, so double check that, putting that in your calculator. If it said leave it in exact form, I would leave, exactly what it says right here, which is 192 pi minus 288 square root of 3. I forgot to say that before. That would be the exact form. And down here would be my approximate form. Okay, on the last problem, my exact would be on example 3 up above, it would have been 16 pi minus 12 square root of 3, or my approximate would be 29.5. So I just forgot to, I guess I can go back, but yeah, this would be my exact because I haven't rounded anything, and then this would be my approximate to the nearest tenth. All right, last problem, big finale here. Okay, made it a little bit bigger. So this says find the area of the shaded region. The circle has a radius of 6. So same idea as what we just did. This one's not quite as much work just because of the type of triangle it is. But again, we're starting off with the area of the circle, which is pi r squared. But once I write that, I realize I need the radius. And I can see, actually I don't need, yes, I do need the radius, but I don't have it yet. Okay. Oh, actually I do. Okay. I should have read the whole problem. It said the circle has a radius of 6. So I can go ahead and find the area of the circle. I've got pi 6 squared, which is 36 pi. So that part's done. Now, in terms of the circle, if it tells me it has a radius of 6 from the center out to the edge is 6, from the center out to the edge is 6. And so I know the whole diameter is 12. Okay. I also can see this is a 30, 60, 90 triangle. If I know the hypotenuse is 12, I can divide that by 2 to get what the short leg is, which is 6. And then if I know the long leg, I can multiply by square root of 3, just 6 square root of 3. So to find the area of the triangle, I can use 1/2 base times height. And because it is a right triangle, the base and height form a right angle with each other. So they're actually just the legs of the right triangle. 6 times 6 square root of 3. Which if I multiply everything except for the square root of 3, 0.5 times 6 gives me 18 square root of 3. So that's my area of my triangle. I already found my area of the circle. So again, I just need to say that the area of the shaded is equal to the area of the circle minus the area of the triangle. So area of the circle is 36 pi. The area of the triangle is 18 square root of 3. If they ask me for the answer in exact form, that would be it. If they ask it for me in approximate form, then I'm going to punch that in my calculator, and I can say 36 pi button equals minus 18 square root of 3, and that gives me 81.9. And that one does not get units because it didn't give me any units in the problem. All right, hope you enjoyed that. Let me know if you have any questions, and have a good day.